Okay, so the next thing we talked about was refraction, so we could introduce lenses. And for refraction, we had only one equation, Snell's law, n1 sine theta 1 equals n2 sine theta 2. So n was the index of refraction, which is basically the ratio of the speed of light in vacuum to the speed of light in the material. And the slower the light travels in that material, the bigger the value for n is. All right, so we're told that light traveling through air enters a container of benzene at an angle of 43 degrees to the normal, and the refracted beam makes an angle of 27 degrees to the normal, and we want to know what's the index of refraction of benzene. So let's draw a little sketch. So I've got, on one side I've got air, and on the other side I've got benzene. We know that air, which is the side we're coming from, so that's N1, air has a refractive index of 1, or at least so close to 1 that we can approximate it, and we're asked what is N2. All right, so we are given two angles. So what are those two angles? Let me get a different color pen. So I'm going to draw in the normal to the surface. So when you do refraction, all the angles that you measure are relative to the surface normal. So we're told that the light coming in through air enters the container of benzene at an angle of 43 degrees. So it comes in like this, and we're told that this angle is 43 degrees, and then it goes into the container of benzene and it bends so that now it's making an angle of only 27 degrees on the other side. So theta 1 is 43, theta 2 is 27. Okay, so whenever light goes from a low index to a high index, it bends towards the normal. If it goes the other direction from a high to a low, it's going to bend so that the angle is bigger, so it bends away from the normal. So what do I have? I know my N1, I know my theta 1, I know my theta 2, and I need to find N2. So I just have to rearrange Snell's law. So N2 is just equal to N1 sine theta 1 over sine theta 2. And the only thing you have to do is make sure your calculator is in degrees, not radians. So N1 is 1 times sine of 43 divided by sine of 27. And I get that N2 is equal to 1.50. Right, so that's pretty easy. It's pretty much just plug and chug, draw a picture, figure out which angle is which. All right, let's do one where we've got the light coming the other way. So now I've got a scuba diver who's in water, and he looks out from underneath the water, and he sees the sun from below the water. So let's draw a picture. So my scuba diver is down here in the water, and he's in, the light is coming from him, so he's in water with the index of refraction of 1.33, so that's N1. So light comes from the water, goes into air, and air we know has an index of refraction of 1. So N1 is 1.33, N2 is 1.0. And then let's draw our normal to the surface. And he sees the sun at an angle of 35 degrees from the vertical. So when he looks up at the sun, so I've sort of got my normal a little bit too far away, he sees that that angle is 35 degrees. So he sees theta 1 is 35 degrees. And so the question is, if he's got another buddy who's standing over here, and his buddy's looking, let me make it green. So here his buddy's green. What angle does his buddy see that the sun is actually at up in the sky? All right, so what's theta 2? So we've got N1 sine theta 1 is equal to N2 sine theta 2, and I've got the two indexes of refraction, two indices of refraction, I guess I should say N1 and N2, and theta 1, I need to find theta 2. So sine of theta 2 is equal to N1 sine theta 1 divided by N2. So that's 1.33 sine of 35, and N2 is 1. So I get 0.763. So what I have is that sine of theta 2 is equal to 0.763. So how do I get the angle theta 2 out of it? Well, you know, you just take the inverse sine, right? So theta 2 is equal to the inverse sine of 0.763. So I get an angle of 49.7 degrees. Right, so in this case, theta 2 is bigger than theta 1 because I'm going from a high index to a low index. If I'm going the opposite way, so if I'm going from, in my problem 3, I'm going from air to benzene, then the angle in the air is bigger than the angle in the benzene. And in this case here, the angle in the air is bigger than the angle in the water. And you can see I drew my picture wrong, didn't I? I should have drawn that picture. I should have drawn my line for the sun's ray at a bigger angle, not a smaller angle.